Welcome back to the classroom. My name is Mr. Wong. Today we'll be covering the Module 2 Inquiry Question 1 exam question from the 2019 PEM Physics Question 27. This is all about force vectors and solving for vector diagrams. So in this question we have a system of two masses held by a frictionless pulley fixed on a ceiling, and we have these two masses linked between. So question A says, calculate the force that the system is applying on the pulley. So the first thing, let's do a couple of force diagrams for each one, and we'll work out where the total force is. So the total force is the force from our 10 kg mass plus the force from our 5 kg mass. As you can see, the contributing factor that this pulley experiences is these two strings pulling down. The reason why they're pulling down is because of these two masses here. Okay, so if we try and do the total force, F10 and then F5, break it apart into the components. So it's because of the masses 10, G is the acceleration due to gravity, and then we have F5 or M5, and then we have G as well. There's two ways you can go about it. You can signal the direction. So we know that the direction is down. So I'm going to call that the negative direction here. So we have a mass of 10 times negative 9.8, because that's where the acceleration is going, down that way. And then we have 5 times negative 9.8 as well. That gives us an answer of approximately, put it in the calculator, 147 negative newtons, or you could say 147 newtons down. Maybe if you're more a symbols type person, you might even write the symbol. Wonderful. Next we go to is calculate the acceleration on the system. Okay, so let's change color and also do another force diagram to work out where the net force or net acceleration is. Okay, so this is 10 kilograms, this is 5 kilograms. By the order of what we've talked about, the 10 kilograms will have a greater gravitational force than the 5 kilograms. So that's by notion of what we can see in this diagram here. Now when we take that into account, we can see that by that idea, the pulley's going to go down here, the pulley's going to go up here, or the string, so to speak. The string is going to be pulled up in this fashion here. Okay, so what we can do is we can say that the overall acceleration, or the net force experienced by our 5 kg pulley here, is going to be to go up in this direction, or we could say the net acceleration is going to be pulled up in that particular direction. Okay, so let's put that into some kind of equation that we can work with. We can say that the overall net force that the 5 kg is experiencing will be due to the gravitational force of our 10 kg subtracted by the force of our 5 kg. Now the reason why we're going for the subtraction of number 5 is because, as we said, the net force is to go in this particular direction, and our 5 kg is being pulled down in this particular direction. So there are two opposing directions here. Okay, so let's work this out. So exactly the same values as we had before. Okay, so do that subtraction into the calculator again. So that gives us a value of 49 newtons, and that in terms of the newtons we have. The acceleration is sort of going in this kind of U-shaped direction. Obviously, we're not going to talk about direction in this case because it's just about the system, but that's the net acceleration or net force that's experiencing on the string. Next we need to find is the net acceleration. That's going to be using Newton's second law of motion, that the acceleration is going to be in the same direction as the force. The total mass of our system is 15 kilograms because the string is attached to both of these masses, so they are considered as part of the same system. Okay, so substitute that into our equation. And we should find the acceleration to be about 3.27 meters per second squared. Okay, and that's how you do question B. Let's look at question C. It says calculate the tension in the rope at point A. Okay, and we'll go with another color just so we know which one we're doing. While we're at it, let's also make sure we use a different diagram to represent. So, A, this is the scenario we have here. We have the net force pulling the mass up in this direction, and this is the net force that our 5 kg mass is experiencing because that's where our rope A point is here. That is being lifted up by the tension force of the string, and that is also being pulled against by the gravitational force of our 5 kg mass. So it's going in the opposite direction in that sense. Okay, so this is the force diagram we're sticking with here. Let's draw it out here again. The net force is going up in this direction. That's because our tension force is here. And then we know our gravitational force is down here. You can see I've purposely drawn the tension force higher or longer than the gravitational force because I want to represent that. That's the reason why the net force is favoring the upwards motion at point A. So let's write this out again. What we know is that this is the net force experienced by our 5 kg mass. Okay, so that's our 5 kg mass being pulled up. So we're going to rewrite the formula as ma as our net force. We know what the acceleration is, that we calculated that in the previous question. We also know what the mass is, so that is going to be 5 times 3.27 equals to the tension force, that's what we're trying to find, subtracted by the gravitational force that is exerted by our 5 kg mass down here. That's going to be that. Notice how I did not account for 9.8 being negative because I already said it's negative in this direction already. So rearrange our equation and we get 27, don't forget the decimal, plus 5 times 9.8, and that will equal to the tension force that we are searching for. This tension force, if we plug it into the calculator, is 65.35 newtons. Now, let's do a really quick analysis of this, because this is the answer, but let's just make sure it follows Newton's third law of motion. Okay, so a quick analysis will show us if we are right or not. If the tension force is 65.35 here, our gravitational force is 49 newtons. Okay, if you check these two values here, you can see that what's actually happening is this force is large enough to pull this 5 kg mass up because the weight force is not strong enough or not large enough to pull it in that direction. Another way we can make sure that we've got the correct tension force is to analyze our 10 kg mass. So 65 approximately, pulling it up. The amount of weight force pulling it down for the 10 kg mass is 98 newtons. So that matches the analysis, okay? The tension force isn't as large on this side, and that's why the 10 kg mass will fall down. However, on this side, it is larger than the weight force of the 5 kg mass, and that's why it pulls it upwards. So that's how you can do an analysis of Newton's second law and third law to work it out. As we can also mention, the tension force is going to be the same on both sides because of Newton's third law of motion. Okay, and so that concludes this exam explained question. Hopefully you found it useful. Give it a like, support for more videos, and until next time, take care and enjoy other videos on this channel.